We are going to talk about describing distributions. And how do we describe a distribution? So there's 4 things we need to remember to include when we describe a distribution, and the way I remember those 4 things is SOCS, S-O-C-S. So the first S stands for shape of the distribution. Is it symmetric, skewed left or skewed right, uniform, bimodal, are there any major gaps? We can look at some examples of what some of these would mean. So you're just basically talking about what the shape of the graph looks like. O is for outliers. So an outlier is any value that falls outside the overall pattern of the data. C is for center. So you're going to state where the center of the data values are. So that would be like the mean or the median. And you can estimate those if you need to. And you would just need to say one of them. You don't have to say both. And then spread is you're describing how spread out the values are. So you can use range, standard deviation, or interquartile range, which is the difference between the lower and upper quartile. That's called the interquartile range. And again, you can estimate those if you need to. You don't have to say all of them, just kind of whatever data is available to you or whatever's easiest to figure out from the graph. You also want to say all of this in complete sentences, so you're writing like a sentence or two, and you're saying it in context of the problem, so you're saying whatever units the problem is in. So let's look at some examples. And actually, first, let's look at some examples of shapes. So these are common shapes that you see in a distribution. Picture that this could be like a dot plot or histogram. So symmetric, you could say bell-shaped. Unimodal means it has one like peak, one mode. This would be an example of bimodal. Bimodal is a word for it has like 2 major peaks. Skewed right means it has a tail going out to the right. It's another term for that is skewed positively. And then skewed left, you have a tail going out to the left. So you have most of the data over on the right and then a tail going toward the left. That's called skewed left or skewed to the left. And it's also called skewed negatively is another term for it. Uniform, just kind of flat all the way across. And then down here we have examples of what a box plot would look like if it's skewed to the right or skewed to the left. So you have for skewed to the right like a longer whisker stretching out toward the right, and then skewed to the left, you have a longer whisker going out to the left. All right, so we have a histogram. It shows the ages of groups of a group of people attending an event, and we want to describe the distribution. So the first thing is shape, and what I like to do is just kind of draw, if you picture there's like a blanket kind of laying across this graph. It would just be flat here because there's no data, and then go back up. And if I look at what that looks like, it looks like you have like a tail going out to the right. So that's what I'm going to say for shape. It's skewed to the right. There's also this gap right here, which you can mention that no one was aged in between 10 and 15 years. It's not a huge gap, but if there's like a really big gap in the data, or like maybe 2 big groups of data with a big gap in the middle, that'd be good to mention. This is just a small gap. You can kind of go either way if you're going to mention that. Outliers, doesn't look like there are any outliers. Center, so the median is between 5 and 10, and the way I can figure that out is I can just count how many total are in this distribution, how many total values. So we have 6 in this first bar, and that means there were 6 people aged 0 to 5. So there's 6 here. And then we have 14 people aged 5 to 10. So the next 14 values were from 5 to 10. No values here. Then there are 2 from 15 to 20. 2 here from 20 to 25, and then 1 down here. So the numbers are already in order. We don't necessarily know what these first 6 ages are exactly. We just know they're from 0 to 5. So this total is 25. So there's 25 values total represented in this histogram. And the median is halfway between those 25 values. So half of 25 is 12.5. So that means the median would be between the 12th and 13th value. So if we listed out all these numbers, there's 25 of them. All the people that attended the event, there's 25. And if we had them in order, their ages in order, the median would fall between the 12th and 13th age. So the median's not in this first bar because that's the first 6 values. The 12th and 13th value would fall in this next bar from 5 to 10. So that's how I'm getting that the median is somewhere here between 5 and 10. For spread, the easiest value to just say is the range. So again, spread is just how spread out the values are. A range is just a really easy way to describe that. So it's about 30, and I'm getting that from the ages are about from 0 up to 30. So range is the difference between the minimum and the maximum value, 30. Then we want to say this in a sentence. We don't want to just list something like this. We want to put it all together in a sentence or two. So I put the distribution of ages is skewed right. The median is between 5 and 10 years old, and the range is about 30 years old. And I've also included context. Context means I'm saying what this situation is describing. So it's describing ages, so I'm putting age in there. So I've included the shape, the center, and the spread, and there weren't any outliers, so I don't even need to mention that. Let's do one more example. So this is a dot plot. Below is the data on the number of goals scored by the U.S. women's soccer team in the 12 months, I should say, prior to the 2012 Olympics in London. And we want to describe the distribution. So I'm going to picture the blanket thing again. You toss a blanket on top of this. It's just going to be totally flat right here. There's no data, and then it's going to pick up again right there. For the shape, there's a couple different ways you can describe this. If you're not counting these outliers, then I would just be looking at this, and you can say it's like slightly, maybe just, again, without the outliers, maybe slightly skewed to the left, or just kind of roughly symmetric. I mean, there's a couple more dots in this little peak, but it's not that high. So again, make sure if you're saying that, though, that you're saying that's not including the outliers. If you are including these outliers out here, you can kind of picture there's like a tail going all the way out this way to these outliers, and in that case, it'd be skewed to the right. You're just trying to give an idea of what the graph looks like if someone wasn't actually looking at it, what the shape would look like. So I'm just going to say skewed right, or roughly symmetric without the outliers. So outliers, they're at 13 and 14. Median, you can just count all the dots, and there were 25 of them. So kind of like the last problem, the middle value between 25 values is between 12 and 13, the 12th and 13th value. So if you just count dots over, so like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, the 12th and 13th values are at 3. So the median is 3. And then the spread, again, I'm going to go with range. So I'm going to say the range is 14 because they go from 0 is the minimum and 14 is the maximum. So if you subtract those, you get 14. And then we're going to put all that together in a sentence or two. So the distribution of goals scored is skewed right with outliers at 13 and 14. The median is between 3 goals and the range is 14 goals. So I've included the shape, the center, spread, and if there are any outliers, and I put it all in a sentence with context. That's it.